Okay, now in the last video on the permanganate laboratory, what I did was I laid the groundwork for the titration, how it's carried out, the difference between endpoint and equivalence, and so on. And usually these labs are completed in two steps. The first step being that we need to determine what the molarity is of the permanganate solution. So, and this is usually called a standardization, which is just sophisticated language for determining to a high degree of confidence the molarity of a permanganate solution. All right, and what I mean by a high degree of confidence is we want to know the molarity to 4 decimal places and of the MnO4 minus solution, because what we're going to do is turn around in a second experiment and use this solution to quantitate an unknown, which in my teaching example here on the videos, what we're going to do is just turn around and use it to determine the mass of an unknown iron sample. All right, but this is a very important chemical reaction in chemistry because permanganate can be used to quantitate a lot of different things. So in the first step, what we're doing is we're finding the analytical molarity of the permanganate solution. To do that, what we did was we massed out an analytical mass of iron 2 sulfate heptahydrate. So it's a mass that we know to 4 decimal places. That was washed into a collection flask using sulfuric acid. The main point behind that was to make sure that we have an excess of the H plus in the reaction, because see, when we look back at the balanced net ionic equation, we need 8 H pluses for every 1 MnO4 minus and every 5 Fe plus 2s. So we set the reaction up in 20 mils. It actually, in my laboratory, what I normally have the students do is use a 1 molar solution. So it's 20 mLs approximately of 1 molar H2SO4. All right, and then we run the experiment. So we begin to dispense the unknown molarity of permanganate out of the burette into the collection flask. I talked about the fact that the solution is going to remain colorless, although there will be a slight yellowish tint to it as the reaction proceeds, because we're producing iron 3, which is yellow. All right, and we eventually reach the equivalence point. I define that, the equivalence point being the point at which the added permanganate ion exactly equals the number of moles of the iron 2 that's in solution here. And at that point, the only things that we have left in solution, so I'm going to write this up here. So at the equivalence point, the only thing in solution in the collection flask is going to be iron 3, Mn plus 2, and water. All right, that's what's going to be in our collection flask at the equivalence point. And then literally, the next fraction of drop that you add to the solution is going to bring us to the endpoint. And the endpoint is going to look like this. In fact, I consider this endpoint a little on the dark side. This should be the very faintest shade of pink that you can detect with the naked eye. That's your endpoint. And what you need to realize is that it's pink because it contains a slight excess of the MnO4 minus anion. A slight excess because you see at that point there is no Fe plus 2 left in the collection flask. All of it has been reacted and turned into Fe plus 3. So the very next fraction of drop you add, you're looking at the coloration of the permanganate ion. And that's why I said in the last video that you're actually going to want to know the volume of a drop so that you can subtract it off the volume dispensed to get to the endpoint. Now, the purpose of this video is to show you how to calculate this concentration. So what we're going to need to know is we're going to need to know the volume. of permanganate dispensed to get to the endpoint here. And the volume dispensed, for this example, we're going to pretend that we dispense 17.9 milliliters of the permanganate solution, for which we do not know the molarity to 4 decimal places. All right, so we've dispensed this much volume to get to the endpoint. Now, how do we find the molarity of the permanganate solution? All right, we start with the fact that we know the mass of the iron 2 sulfate heptahydrate, and for simplicity's sake, I'm just going to call it a half a gram. Although when you do this for reals, you're going to have 4 decimal places here. So we're going to start with a half a gram of FeSO4.7H2O. All right, and we're going to find the moles of this. So we're going to use unit multiplier method. It's going to be 1 mole over 278.31 grams of for the molar mass of this material, and what you should get is going to be a value that'll be 0.001797, and I'm not being careful here with significant figures or anything. What I'm concerned about is teaching you how to do this. So you're going to have to deal with your teacher on that end of things. All right, and this is going to be Fe plus 2. That's the moles of Fe plus 2. And if you're wondering how I made that transition, note this, that 1 mole of the whole salt, all right, is equal to 1 mole of Fe plus 2. See, the Fe in here is in a 1-to-1 mole relationship with the entire compound. So that's how I end up going from here to here. All right, now we're going to be multiplying this. Keep in mind that what we've got here are moles of iron 2, and the iron 2 is related to the permanganate by a 1:5 ratio. So we're solving for the permanganate, and that means that 1 mole here of MnO4 or minus needs to be in the top of this fraction. And in the bottom, we're going to have 5 Fe plus 2s, 5 moles, all right? And this Fe plus cancels with this Fe, and we've solved for MnO4 minus at this point. All right, and what we're going to get is 0.003593, and that's moles of MnO4 minus. All right. Now we're almost home free. We know how many moles of MnO4 minus it took to get to this pink endpoint. All right, and what we need to do now is find our molarity. Keep in mind that molarity is equal to, in units, to moles per liter of total solution. So this is where we're going to need to know the volume of the permanganate solution that got us to the endpoint. So I'm going to rewrite my moles of permanganate like this, and we're going to be dividing it by the volume dispensed in liters. All right, in liters. So there's 1,000 mils in a liter, so we're going to be dividing this number by 1,000. So the bottom of my fraction is going to look like this. It's going to be 0.0179 liters. And so the molarity of my permanganate solution is going to be 0.02, and I'm just going to add 2 zeros here to emphasize the fact that when you do this for real, you're going to be getting a number here that is the analytical concentration that will be known to 4 decimal places. All right, so this would be the molarity of the permanganate solution. It's the analytical molarity. It's the analytical molarity. So now we can use this molarity to calculate the mass of an unknown iron solution, for example. Or maybe, it depends on what your teacher's going to do. It could be oxalate. It could also be hydrogen peroxide. In any of those cases, though, just keep in mind that you will have to create a new equation for it and rebalance.